Hi, hello. I am Mutturaj B. Kadapatti, 8th semester B section, Mechanical Engineering student of RV College of Engineering, Bengaluru. I am presenting a technical seminar presentation on the topic Repair Techniques for Damaged Fiber Reinforced Polymer, FRP composites in aerospace applications. And this is submitted to Dr. Chandrakumar R, Assistant Professor, Department of Mechanical Engineering, RVCE. Coming to the background studies of this particular topic, over the last 2 decades, the repair of existing engineering structures using fiber reinforced polymer composites has attracted a great attention by aerospace industry, as it is more economical than replacing a new. With an increased use of composite material in aerospace field, it is thus essential to restore the structural integrity by repair of damaged part. Concerns regarding the long-term durability of composite repair bonded joints have been a major obstacle for critical component of aerospace structures. Glass fiber reinforced polymer composites diversified the reach for replacement of metal alloys with a market forecast of 77.93 billion US dollars by the end of 2026 in almost all the industries. Fiber reinforced polymer composites have found diverse applications in aerospace, automobile, construction and marine structures due to its high strength to weight ratio, durability and corrosion resistance. Metal alloys are replaced with FRP in major structures. Let me introduce about this particular topic, that is repair of or repair techniques for damaged FRP composites in particularly aerospace applications. So outstanding properties of fiber reinforced polymer composite materials lead to a wide application in all the sectors such as aerospace, automotive, marine, sports, industries and even in the civil infrastructures and etc. Since the last decade, an enormous use of composite materials in the aerospace sector has caused an increasing need for repair technology of damaged components rather than replacement with a new component. Composite structures in service experience damage that comes from the accidental impact and mechanical or environmental conditions. The main environmental threats are related to the effect of temperature and moisture absorption, which can affect the strength of composite structures and reduce their service life. Let us move on to the repair techniques which are already have been found from some of the researchers in the field of damage repair of composite structures, especially FRP. So composites are increasingly being used to repair both metallic and non-metallic composite structures. There are different types of composite repair bonded joints available as shown in this figure number 1. You can notice the type of composite repair bonded joints in figure A, B, C, D and E. Figure A shows the scarf repair technique. Figure B shows stepped scarf repair method. Figure C shows scarf doubler bonded repair. And figure D shows patch repair. Finally, the figure E shows stepped lap repair. The most common types of repair carried out with composite materials in the aerospace industry are external bonded patch repair and scarf repair. Both repair techniques differ from each other in terms of manufacturing and application point of view. The scarf repair joints requires a special equipment to remove the considerable amount from parent material. So so it is preferably used for thick laminate composite. On the other hand, external patch repair is relatively simple and faster. Hence, it is widely used in aircraft to keep an aeroplane in serviceable condition. Considerable experimental and numerical studies have been conducted to optimize the geometrical parameters of external patch repair and scarf repair joints for the better performance of the composite repair. However, designing an optimum scarf and patch repair of composite structure is complex due to an unpredicted environmental condition during service period in terms of temperature and moisture, as we discussed. The application of adhesively bonded joints is widely used for the composite repair in aerospace structure because of the design flexibility, more fatigue resistant and higher damage tolerance than the other joining methods. So adhesive bonding method is already a well matured and developed process and was reviewed by many authors. Many researchers studied the performance of adhesively bonded joints under the influence of different geometry and material parameters. Adhesive bonded repair in composite components are well established and developed in the aeronautical industry. However, it is mainly restricted to the secondary structural component due to the limit imposed by the fail-safe criteria. Many researchers conducted short-term tests subjected to environmental conditions by changing a number of variables such as the adhesive material, composite patch material, patch geometry, curing temperature, and etc. in order to determine the performance of repair bonded joints and optimize the joint. Let me introduce some of the important type of repair methods in detail which are going to be implemented for the repair of damaged FRP composites. Among all the methods, here I mentioned some of the important four methods in detail. The first method is resin injection. Resin injection is a repair technique used to bond the small damages caused by delamination and disband. Resin is injected to the damaged area to restore the local stiffness and stability. Injection method takes place by drilling a hole in the defective area and filling it with the resin. This figure 2 shows the resin injection repair setup. You can easily go through this figure and you can come to notice that how it is going to happen. Basically, in a resin injection method, the damage area is going to be identified. Once the damage area is found, the hole is drilled at the center for the injection of resin as shown in figure A. So that resin is injected through the central hole, and at the circumference of the cracks an even number of small holes are going to be drilled, which are called as vent holes. And once the crack is filled, the resin will come out from these vent holes, which will indicate the proper filling of the crack. So this is the basic mechanism of resin injection method. The second method of repair is chopped fiber. The damaged area of any composite structure where the stiffness restoration is not feasible by resin injection alone, then the chopped fiber method is used, where the fibers and resin is filled randomly to the area to restore the stiffness and stability. Chopped fiber filling will not have particular orientation in fiber. This is one of the property of chopped fiber, where there is no particular orientation of fiber. You can notice in figure number 3, that is chopped glass fiber. And this is the continuation of resin injection, where both resin and chopped fiber will be filled in order to repair the crack. The third method of repair is bonded patch repair. Figure number 4 shows the bonded stepped and scarf repair method. So the bonded patch method is an extensively used method for composite repair for strength restoration of damage in a greater extent. The bonded patch repair is popular due to its minimal weight addition with surface flushed repair. So the repair is structurally efficient as compared with other repair methods. So bonded stepped and scarf repair method you can be get through from the figure number 4. So we can tell that from the many of the researches that has been done on this particular topic. So the bonded patch repair is most efficient type of repair method compared to all other repair techniques of FRP composites. The fourth repair method is bolted patch repair. So the bolted patch repair is used for damages of size similar to the bonded patch method. Bolted patch repair is shown in figure number 5 is a repair joint consisting of mechanical fasteners which causes weight addition leading to the movement due to eccentric loads. The balancing of system will be a concern for this repair method. So the method is not preferable by many of the researchers and industry because of the reason that this type of repair method leads to the stress concentration on the structure, which further leads to the failure or crack in the structure. And balancing is also one of the major problem of this kind of repair technique. So this is not most probably preferable method as per the researcher. Let me conclude the entire technical seminar topic with these few points. In recent years, many developments have been made by researchers to improve the environmental resistance of the composite structures, such as new advanced composite and adhesive materials, curing method, manufacturing bonded joints method, and etc. Hence, there is a strong need for improving the current composite repair subjected to environmental issues such as moisture, temperature, etc. for reliable and repeatable repair. In this review, several scientific challenges and opportunities have been identified in order to develop more durable and cost-effective composite bonded repair technologies with short repair cycles. Aerospace industry demand for lower frequency of repair and maintenance of the composite structure, and this can be possible by introducing the self-healing materials which can help to improve the durability of the structure. Also, composite bonded structures should easily disbond without damaging the structure. Then it can be used for reuse and recycle. And these are the some of the references through which I have collected the information to present this technical seminar presentation. And if there is any suggestions and corrections, I am open to take, and please give the suggestions if there is a need. And thank you.